This experiment is to measure the Young modulus of a strawberry lace. Hopefully you've watched the video at this point, the first video, which shows you what the Young modulus is. And what we're going to try and do is measure the Young modulus of a strawberry lace. So what we need to fix our strawberry lace at the top, and then we're going to add a mass at the bottom, and we're going to see how much the strawberry lace extends. Now the graph that this should produce for a strawberry lace looks like this. So we've got the stress on the y-axis, we've got the strain on the x-axis, and it would produce a graph that starts off straight, curves over a little bit, and then does this kind of stuff where it breaks. Now the Young modulus is the gradient of the straight bit of this graph. It will then curve over a little bit, and then at this point here, this is what we call the yield point, and it undergoes something called necking, and it basically extends very far without you having to add any extra weight. Now this part of the graph here you cannot measure using the method that we are using. You need one of those machines that was in the first video, because it's just going to keep stretching and keep stretching and keep stretching very, very quickly until it snaps. Now you are not going to be able to see that. Well, you'll see it, but you won't be able to take measurements because it happens so quickly. When we're analysing our results, you can ignore this section here. Don't put them in your graph, we just want the straight bit if you've got enough results for that. So we need to be able to calculate this. So stress is equal to force divided by area. The force is coming from the mass that we are putting on the end, but to turn a mass into a force we need its weight, so we times it by gravity. So we're going to say it's the mass times gravity divided by the cross-sectional area. Now normally we would use something called a micrometer to measure we measure the diameter of the object that we're measuring, but you don't have one of those at home, so we've had to come up with a different way of doing it. And what we're going to do is, because our strawberry lace should be red, is actually a very, very thin cylinder, and the volume of a cylinder is V is equal to the length times by the cross-sectional area. So that's the cross-sectional area, and that is the length. So if we knew what the volume was and we measured the length, then we could work out the cross-sectional area by dividing the volume by the length. The strain is equal to the extension divided by the original length. So that's going to be the length minus the original length divided by the original length. Now I've got a spreadsheet that I've set up for you to do all of these things, and that will do all your calculations for you. Obviously if you come and do physics you'll need to be able to do these calculations with a calculator, but we're going to do it with a spreadsheet. We're going to use Google Sheets, and we'll show you how to enter that data. The first thing I need to do is measure the length of my strawberry lace. So get it as straight as you can, but don't pull it because it will stretch. So the best I can do from this is say that this is 52.1 centimeters, or 0.521 meters. In order to calculate the cross-sectional area of my strawberry lace, I'm going to do it via volume. So I've got a jug, I've put exactly 300 millilitres of water in it, and I want to see how many strawberry laces it takes me to get up to 340. You want to do this adding one at a time. If you try and pull stuff out, you're going to pull some of the water out, which means you're going to need to start again. Then you need to dry your strawberry laces, so it's a bit of a faff. So do it one at a time. So I'm going to add them one at a time until I get to a volume of 340. That's 2, make sure you're counting. 3. It's helpful if you kind of coil them up to make sure they're all under the water. Any like that are just sticking above are going to mess you up. 4. So you can see with 16 strawberry laces, I'm now at 350 millilitres. I started with 300, so that means that 16 strawberry laces take up 50 millilitres. As you can see, I've got my strawberry laces holding onto this bottle. I'm going to count this as 0. I mean, even though the bottle has some weight, we're going to measure our first distance from this, and then we're going to add water into our bottle. I've put a cap on the top because this is probably going to break and we don't want water all over the floor. So I'm going to do my marker first. I'm using a permanent marker. Please don't eat the strawberry laces after you've marked them with permanent marker. I believe they're poisonous. And then I just want to do, doesn't really matter how far apart these guys are, we just need a marking. And what I'm going to do is I'm going to measure the distance between the markings, so from the bottom of the top one to the top of the bottom one. I'm going to measure that distance. I'm going to measure that distance. I'm going to use my tape measure. Please remember when you're doing this that to avoid what we call parallax error, you need to make sure your eye level is on a line with both the reading and the mark. So that's the first bit. So this gives me an initial reading of 5.1 centimetres or 0.051 metres. I'm now going to add 100 millilitres of water, and because the density of water is 1 gram per milliliter, that's 100 grams. Now when you're doing this, you want to pour the water in like this when you're holding on to the weight. We're not going to let go at the end, we're going to lower it gently because otherwise you get an extra jerking motion which weighs the strawberry laces down an extra bit. So I'm going to add it, gently let it go. Wait till I can see it stop stretching, and I'm then going to measure my length. My length, oh, stop it swinging. Pendulums is a different topic. .7. I'm going to add an extra 100 grams. This now gives me 200 grams in total. Once again, I'm going to lower slowly so I'm not getting that extra jerk. And I'm going to measure my distance again. So that's 7.8. And that is why we have a lid. So I only managed to get 3 readings there. I would have liked a few more, but we'll see what we can get with 3 readings once we put the data into our graph. When you click on the link, you will get this page here. So we're going to click on make a copy so that you can enter your results into your version of the spreadsheet. We're using a spreadsheet so you don't have to do all the graph drawing and the calculations. I've decided to use Google Sheets because you might not all have Microsoft Office, and this version is free. And even if you did, the online version, which is what certainly many of my students have used from school, doesn't have all the features that you need. So we're going to use Google Sheets. You will need a Google account, but you can sign up for one of those. They are absolutely free. So I've color coded all the squares, which you can change. Don't change any of the other ones because they've got formulas and stuff that do all the maths for you. So first of all, we're going to look at the volume of the laces. Now I used 50 milliliters for this. I'm expecting you to do the same, but if you use a different value, you can change that value there. Now for that, I had 16 strawberry laces that took up my volume of 50 milliliters, so I'm going to put 16 in that box. Now the total length of the lace, that's not the distance between the two black marks when you're actually stretching it, but the length of the strawberry lace that you're putting into the water, I measured that as 52.1 centimeters, but I need it in meters, so 0.521 meters, and that gives me a value for the cross-sectional area, which is a tiny value, but then we're expecting a tiny value. Now the number of laces that I used in my actual experiment bit, where I was adding my weight, was 8. You put in the value that you used, and then we have to put in our lengths. Now the first one is the original length, not of the whole lace, but between the two black marks on your strawberry laces, without adding any extra water into our bottle. Now this was 5.1 centimeters, but I need it in meters, so that's 0.051. Now that gives me an extension of 0 because I haven't actually extended it any, and I've got a strain of 0 as well because I've got no extension. So my next value was 6.7 centimeters, 0.067 meters, and my next one is 0.078, so 7.8 centimeters. Now I've got 3 values there, and you can see I've calculated the stress and the strain. It's drawn my graph, and then it's given me the equation, and it's this number in front of the x, that is 76.4, and that is my value of Young's modulus. So it's 76.4 kilopascals. Young's modulus is the value for this strawberry lace. And if that seems large, it's not really, because typically for steel or something like that, or the kind of stuff you would actually do this experiment with in the class, it's about 10 to the 11 rather than 10 to the 4 here. So that's telling me I don't need very much force to stretch my strawberry lace. If you've got part of your graph as a curve, you can always delete a length and then till you get a straight line, and that will give you your result there. But I'm going to put mine back in. There's a little bit of scatter on that, but it's a perfectly acceptable straight line. So there you should be able to measure the Young modulus for a strawberry lace.